Welcome back, guys. In last video, we talked about classification. We talked about two types of classification. One of them was binary, then there was a multi-class classification problem. In binary, we had two classes, whereas multi-class classification, we had multiple classes. We also talked about linear regression, where we make a line. The equation of line is y equal to mx plus c. Then we said we can pass it to a sigmoid function to get this within the range of 0 to 1, which is range of probability. Then we set up a threshold over that, and we said that we are getting our two output classes. So this is how the logistic regression work. Then we also discussed about the loss function of logistic regression. We also derived how we can get it. In this video, we are going to look at the practical implementation of logistic regression. So what we will do, we'll take a very basic example like height. Okay, height is a relative term. So let's say I have this person who is 160 centimeter long. In my place, this is called a tall person. So basically, in my place, after 150 centimeter, you will be classified among tall people. So I have another person who is 155 centimeter. Then he's again tall. And then there is a person with 145 centimeter. Okay. And then we will say, okay, he is not tall. Okay. And then there is 125. Okay, maybe some kid, so we say he's not tall. And then there comes a man with 180 centimeter. We say he's definitely tall. Okay, so height is a relative term. If you go down to somewhere different, like you go to some different country, they will have different standards for tallness. So height is something relative. So what we will do, we'll say, okay, let's classify it like this. Okay, after this they are tall, and this is not tall. So we have basically two classes. We could have taken a better example, like let's say that we have an image. Okay, we have an image of a boy. So what happens in an image? We have this image have numbers of pixels, right? Pixels would be like small squares. Okay, and then okay, these pixels are of various types as well. Let's say we have an RGB matrix, right? Red, R, G, and B. Red, blue, green, and blue. And then there's a blue matrix. Okay, this is how we have color matrix. Then these matrix, each pixel will have a value like from range of 0 to 255. Okay, uh, and then what we will do, we will convert it into an array, and then we will pass it into a neural network. So it will also have convolutional layers, ANN, pooling layers. There are various several layers, and there are very advanced concept behind that. So if we just take that example, it will be hard for you to guess. So we are going to stick with a basic example of this height. Okay, and in the even in this example, you will have this question, right? That you could have done this if height is less than 150, print okay, it is not tall, and else print tall. And you are right about this. Okay, you are actually right about this, but we do not want to just hard code everything. We do not want this hard code thing. Instead, we want the machine to learn by itself that which is tall, which is not tall. Okay, which is tall and which is not tall. So in this example, we will let the machine to use logistic regression to train itself to classify this not tall and tall thing. So let's say how we are going to do that. We will again use scikit-learn for that. And if you do not know how we are, or if you see that you are not able to grasp this thing, you can just roll back to the earlier linear regression video, because the logistic regression is actually based upon the linear regression, right? So let's have a look at the data we will use. Okay, so we'll have this x. Let's say this person is 125 centimeter long. Okay, 124, 130, then 160. This one will be a tall person. 170, 187, then again 145, and 152, right? And then we will need See, this is a supervised learning, right? So we need to provide labels. So 124 will be a short person. In this example, we will say 0 is for, okay, 0 means not tall, and 1 means tall. Great. So 124 is not tall, then what, 130 is again not tall, 160 is a tall person, 170 is also a person, 145 not tall, and then 152 is a tall person. Right, this is it. Then we need numpy. Okay, numpy is np. Great. And we also need scikit-learn. So what I will do, from sklearn dot linear model, I will import logistic regression. Okay, logistic regression, and I also need an instance of this logistic regression, so I will say model equals logistic regression. Great. Till now it is very clear that we want a logistic regression model, and we got it right. Now what I will do, I will say, okay, x train equals np dot array of x. Okay, and I also need to reshape it. X train dot reshape, I will reshape it into the same number of data slash 1. Why I did it, you can just see in this video of linear regression we did that, right? Um if it's not clear, I'll explain it. Okay, uh, what happens in linear regression, we said, in linear regression we said y equal to mx plus c. In real life scenarios, this m is a matrix of slopes. Okay, this will contain many slopes, because it is not always the case that we have only one slope. In multivariate linear regression as well, we will have multiple variables, so we will have like x1 y1 x2 y2, something like that. So we will have multiple slopes as well. So for each plane we'll train a slope. For x is matrix of features, we will have multiple features, as well as we will have multiple training examples. So we will multiply these two, right? And in order to do basic multiplication of matrix, we need this condition, right? The column of this matrix should be equal to the row of this matrix. So we do this, right? W transpose x, this weight matrix is the slope matrix. Okay, and then we have this c is the bias term, and we will just add it. So multiplication of this is added to this, and then this numerical value is the y hat which we predict. So this is actually y hat, then we compare this with y to figure out the loss. Great. So to make this matrix multiplication feasible, we need to reshape that matrix, because we had only one feature, so we reshaped it into one, right? So here I am reshaping it into 1 to make that multiplication feasible for me. So when I did this, after that what I will see, this x train dot shape, see, it became 7 comma 1, because we have 7 training examples, 1 2 3 4 5 6 7, and 1 is for that matrix balancing. And then again I will need to convert a numpy array for my labels, right? But labels, I do not need this line. I will only need this x, and I will replace it with y. That's it. And then when I will do this y dot shape, y dot shape, sorry, it is y train, right? And see, this is 6 comma nothing. Okay, because these are independent labels. And then what I will do, I will train my model. Model dot train. Okay, I will pass x train and I will pass y train. Okay. uh, okay, we have this fit function, not train function. I'm sorry, what happened is inconsistent labels, right? Okay, we haven't passed labels for everything. So 0, 0, 1, 1, and then for 187, 187 is also a tall person, and then 0 for 145, and then 152 is 1, right? Again, we need to do all this. So for 7 training examples, we have 7 labels, and this should work now. So I will train my model based on that, and this time the model has trained successfully, right? So for checking the training data, I will say just model predict it for my training data. Predict it for my training data, X train. Okay, I'm getting this thing. Okay, let's store this value in y hat. Y hat, great. And I will check if this y hat is actually equal to the y train. So we are getting all trues right, means the model is performing really great on the training data. Let's build a test data. Okay, x test equal to, let's say there is a person of 123 height, it will be a short person. Then there will be a person of, let's say, 167, this is a tall person. 148, okay, 153, right? And then what I will do is, again, x test equals to np dot array, and I will pass x test, great. And then I will do x test equal to np dot reshape, and then I will pass -1 comma 1. And okay, I am doing np dot reshape, but I have to reshape x test, right? uh, and then I have to do model dot predict. What I have to predict is x test and see what I am getting. Let's say this x test, and see 123 is a small person, not tall person, so I'm getting 0. Okay, 0 is labeled for not tall. And 167 is a tall person for me, so it is saying okay, it is tall. Then 148, 148 is not a tall person, because we said 150 will be the deciding criteria for that, right? So 150, it is smaller than 150, so 148 is not a tall person. Then 153 is above 150, so it is saying okay, it is tall person. So that's how we decided this criterion, and we built some line like this. Okay, this line, this particularly yellow line, is the line we decided that after 150 the person will be classified as tall, otherwise not tall. So 0 is for not tall, so this 0 is for not tall, and this 1 is for tall. Great, so that's it for this video, and we shall look at more better example, or probably we'll implement a entire model for the regression or classification problem in the next video. And that's it for this video. Thank you. Take care. Goodbye.